Hi, Ahava. Hi. Today we're doing something slightly different because I wanted to introduce algebraic proofs to you in a slightly different way. So I am looking in your book literally at page 113 down here. Isn't that cool? So I am looking in your book and I'm doing this with my phone, so be patient with me. It's going to move and stuff. Probably going to make you sick or dizzy or something, but it happens. They want you to name the property of the real number illustrated by each statement. So for this one, it starts out as 5 plus 9 equals 9 plus 5. So from the left side to the right side, what changed was the order of stuff. That's why it's the commutative property, incidentally, of addition, because there's a plus there. Down here, what moved from this side to that side is the parentheses. It went from being around the 7 plus x to being around the 3 plus 7. So since the parentheses moved, that's the associative property of addition, because we're dealing with addition. Over here, looking on this side, up here you have the 6 on the outside and then the 2/3 plus 4 on the inside. And they distributed that 6 and gave 1 to each of those numbers. That's a distributive property. It doesn't have a of multiplication or of addition because it's both, so we don't say that for them. For number 4, it says 8 times 1 equals 8. What it started out as is what it ended up as. That's the identity property of multiplication because it's times 1. So when you look down here, they broke down commutative property of addition and multiplication, associative property of addition and multiplication, inverse property of addition and multiplication, identity property of addition and multiplication. Then they have the distributive property, the property for multiplication of 0, property for -1 with multiplication, definition of subtraction, definition of division. Turn the page. Yes, there is more. Aren't you glad I'm not making you write all these down? Because I could. Just saying. The reflexive property, which says what it starts out as is what it ends up as. In other words, it equals itself. Symmetric property, if A equals B, then B equals A. Transitive property, A equals B and B equals C, then A equals C. The substitution property, which you use quite a bit, but we don't generally call it that. We could say simplifying, not necessarily substituting. And then down, okay, not down. Just kidding. So, when we look at the class exercises up here, let me see if I can make it a little bit better. I'm trying to steady my hand. It's not exactly working out. But anyway, when we look at the class exercises, they have a proof written here. And I wanted to go into some detail on these proofs because you're going to do them a lot when we get to geometry. And these are the only proofs that you're really going to get in algebra, so it's your first introduction to proofs. Anytime you have a proof, they're going to ask you to prove, and they have to use that word. They have to say prove. Prove for all real numbers a and b that a plus b plus negative b is equal to a. So they throw that up there, and then they want you to prove that. So you always start with what's given. That's why they wrote that there. And then your last line should be what it is that they want you to have. And in between, all you're doing is reducing stuff down. So I'm going to go into more detail with this on the board, but I want you to understand some things about proofs. Number one, it's always going to have a statement side, and it always has a reason side. For us, those reasons are properties. All those properties we just looked at, they're all considered reasons that we could use. They're like tools in our toolbox for proofs. And the same thing down here for problem number 2. They kind of told you the stuff that they wanted you to prove, and then they ask you how we're going to prove that. So we're going to look at this classroom exercise up here, and then we're going to talk a little bit about problem number 2, I think. I think that's what we're going to do. So anyway, I will see you in just a second. Okay, bye. So I'm saying so far this has been a pretty different lesson for you. What is written on the board is also written in your book, so you shouldn't have a problem with any of that. I know it's kind of hard to see on this because I wrote it with such a light color, but it is all in your book. This is the classroom exercises. What they asked you to prove, statements and reasons. All I'm going to do is fill in stuff, and I'm writing that in a much darker color so you'll be able to see it better. Likewise, down here is the classwork that I'm going to have you look at to see if you can figure out what changed, and then we'll talk about what you should call all of it when you fill it in. So up here, when we go from what they gave you or the given to the next line, which I wrote subsequently so you could kind of see it better, when you go from this one to that one, the only thing that changed is instead of having the grouping around the A and the B, now it's around the B and negative B. What property is that? It's the associative property, incidentally, of addition, because that's what we're dealing with. So that's the, helps if you spell it right, associative property of addition. It's okay to abbreviate. As long as you use 5 letters to abbreviate, you're good. So then, when you go from here to here, when we have B plus negative B, what does that equal? It equals 0. So I can fill in my 0. What did I just do when I said B plus negative B equals 0? What property is that? That's the inverse property of addition. And then when you look at A plus 0 equals A, that is the identity property of addition. So you go through and you look at them, and you've had enough practice, I hope, with the properties to kind of be able to tell what's what. Now the next one that I give you for classwork is pretty challenging, because you've really got to make sure you go and you look at all the properties, because I know you know that it's true. I don't think you would question the validity of what they're saying, but knowing what to call it is what we're talking about here, because you have to know what to call it. So I want you to take some time and figure out what you think each thing should be called. It's problem number 2 in the practice exercises. They tell you to prove that negative parentheses x minus y close parentheses plus parentheses y minus x close parentheses is equal to 2 parentheses y minus x. Notice the very first line starts with what they asked you to prove, and it has to equal what the very last line is. So I have steps 1 through 3 here, and then steps 4 through 7 over there, because you know I don't have a whole lot of room here for me to write it all down. So I'm going to give you a second. Go ahead and pause the tape and see what you can fill in. And it's okay if you don't get it right, because I know you're writing in pencil. So that way you can go back and fill in with pen when you know for sure what the answer is. So pause and give it a few seconds and see if you can figure out what each thing should be. Look at what the properties are and what they all say before you try to jump and say what it is. If you can't find a property to match it, just say what you think it might be called, and then we'll talk about it in a little bit. Okay, so the first one they said was a definition of subtraction. And their definition for the definition of subtraction is changing this right here, the x minus y, to x plus a negative y. They're calling that the definition of subtraction. What changed from here to here? Well, they put a 1 there. So now it's a negative 1, not just a negative. And that is the property of negative 1 for multiplication. property of -1 for multiplication. Put a little dot for my multiplication sign. Then from here to here, what changed? Well, they gave the -1 to each of those. That's the distributive property. Then from this line right here in 3 to that line in 4, what changed? Well, they went from having a -1 to just having a -x. So they did this multiplication in here. So once again, that's the property of -1 for multiplication. Because that's what they did. They multiplied -1 by each. Then from here to here, they did the commutative property of addition, because the -x moved here and that y moved here, and all of them were added. None of them were multiplied, so it has to be commutative property of addition. To get from here to here, this was the hard one. We know that y plus y is 2y. We know that -x plus -x is -2x. So there are a couple of things I would have accepted here. I would have accepted the definition of addition. Or you could have simply wrote simplify, and I would have been happy, because that's what they did. They simplified the statement. You could have wrote combined like terms, because that's what they did. They combined the like terms. Either of those would have been fine with me. Then, to get from here to here, they did a backwards version of the distributive property. We'll talk about what that's really called later on in chapter 7, 8, something like that. It's on up in ways. So anyway, that is a crash course in proofs. We're going to do a lot of those when we get to geometry, because it helps you to understand geometry better. But these are the only kind that you're going to get in algebra, so with the properties and stuff. So the homework, because we just did the classwork, wasn't that great? I went over the classwork and everything, so you know all of it. I had to do that because you know the last one had all those different answers to it. So the homework for this section, you're going to love this, is practice exercises. Number 8. Yep, that's it. Just one problem. Now, if you look at it, it's not a short problem, but just one problem. Do the best you can. The answers are in the back of the book. Oh, the answers aren't in the back of the book. I will put the answers on the classwork, so you'll be able to check it with your mom. So I guess technically you could just call it classwork and not homework, but I want you to put it in the homework section. Okay? I will see you probably later on today, but we're going to call it tomorrow because it makes me feel better. Alright, bye.